Hi everyone, Assalamualaikum. Now we start to tutorial 2, how to solve resultant force. Yeah, we got waste the time. We try to answer as we know what you learn in the class before we start the solving. So we create the uh, like the BBB, of FBD. I mean FBD. So create the force direction first, multiply direction here. Okay, we have 1, 2, 3 force here, uh, here, here, and also, sorry, here, here, and also this direction. Okay, we have F1 here, sorry, F2. Also, we have the F1 here. Then the last is the F3. So we have 3. Okay. Okay, every force direction varied by two axes. The first one in the X and the second one in the Y. Also for all force, which will be sum of every force in the all direction. The first we try to calculate in the X direction. So we have 3 of force, so it should be multiplied by F1. We can check F1 here. So in the X direction, we multiply by cos 45. And then here we have F2, 800. Sorry, F2, it should be the symbol first. F2 multiplied by X direction sine 60. Okay. I can remove the thing here. Two. Okay. Okay, now we add the last force, F3. In the X direction should be sine 75. Okay, 75. Now in the Y direction, also just repeat the F1, 1, sinus 2, sine 5 degree, and then F2, we have cosinus the last one, f3 into cosinus 7. Now we can add all calculation for f1 to f3. So for fx, I got the answering is negative 700 3.24 meter. And then y I got, okay, you can calculate by yourself in this part. I got 700 7 in 8 meter. Okay, based on the condition, this condition, you can describe the direction of force as, so fx in the positive, fx in the negative, while the fy in the positive direction. Yeah. So somewhere, maybe the resultant is somewhere here in quadrant 2. Of course, it's quadrant 2. This is the resultant. So how to calculate resultant? Is by s square plus z y square. Okay, from my calculation, so I got the around 900 7. You can, so resultant you can get from this formula. After that, back to the question, measure the clockwise from the positive x. Yeah, from positive x. So should be the angle should be from here until to here. This one the question. Okay, how much? So before that, before we calculate the theta, we can calculate from here first. Maybe we can call this part is the alpha. We can call the alpha. So first, the alpha, we can calculate by sinus inverse x over y. Yes, calculate this one because x already defined and out, and then r also already here. Just input here, and then inverse cosinus. You can get around. So I got around 35, 105 degree. Okay, so how much the theta? Just calculate the theta. 180 negative 2 5. Yes, this answer. So this is considered easy. Okay, for your finalizer answer, please complete and then submit to me within 1 week. Yeah. From this answering, I will consider your attendance as tutorial class. Okay. This one is answering for question number 1. Now we go to question number 2. It's quite easy, yeah, compared to the number 1. We just use 2 force here, which I think more easy. Yes, sorry. Wait, the second force here, just make the parallelism, yeah, parallelism using here, maybe over here, yes. Then, yeah, we complete the force. Okay, so the resultant will be the resultant. Okay, because of this one to reflect to the y, and then this one reflect to the x, yeah, the x like this around 45 degree. And then how much is it? Just this how much? That one we can call theta maybe. Maybe theta. Okay. Um. Then we try to calculate the theta first. How much? Theta equal to 180 and negative 60 and yeah, and equal to 34 degree. So 180 is total in the half of circle, and then 60 is come from the uh, within the x, okay, this one x and the angle of this one, and then 45, okay. Sorry, this one is Yes, yes, that is. Okay, after that, you can using the resultant formula. So we are by u square equals to b square, and then negative 2 a b c cos 75. Okay, we can get the r is somewhere here around 7 in actually. Okay, for that, application, the magnitude of the resultant force and its direction. Already we can magnitude already there, but the direction. So the direction we can calculate by using formula sine over the over sine the timing is 1 gamma is this. Okay, for that you can choose whether this one relation is with the A and B or B and C. You can choose. Okay, after that, if you choose the sin alpha, sinus alpha with the sinus beta, you can calculate the formula. R, sorry, R is not 70. Sorry, R is let's do it again. R is 300 something here. Three point two Newton. Okay. And then theta, you can use 2, 3, 4, 2, 2, cos sin 25. Sorry, remember. Okay, now you can compare to 250 by sinus theta. So you can get the theta equal to 47 and 51 degrees then theta equal to 300 because one unit is 5 plus 7 9. So the total 30 100. So because we calculate the angle is counterclockwise, correct? So from here into yeah, yes, is the angle. Okay, this is the question number 2. For number 3 until to number 7, yeah, we use the same method. We use the same method, just repeat. We use a formula, and by using number 1 also, if you have two force, you can use to force by this formula, resultant formula. With the more than 2 force, you can sum by every axis. With the 2 axes, x and y, you sum the x and y. If you the question have the 3 axes or 3D, you should be sum by each axis x, y, and z. Okay, I think this method similar until to number T12. T12, we just add one more axis with z only to calculate. We can use simplify by using the resultant x square plus 2y square square root. Yes, only that. Now we go to number number 12. Okay, now we try to continue. Later we try to solve number 8. Number 8, actually, every single force have 3 the axis direction to analyze. Okay, back to our question. Determine the magnitude and the coordinate direction angle by resultant force. Every single axis, x, yeah, y, and z. So one force reflect to 3 axes, whether x, y, and z. Okay, if we see the force one, yes, here, force number 1 is only have 2 direction, y and z. How about the x? X is considered 0 because the direction only have in a field x, y and z only. Yeah, y and z. And then if we see, check into the Western number, Western number, force number 2, force 2, yeah, with the direction of a certain angle of the in the x 60 degrees and also have the Z in 30 degrees and also have the certain degrees in the Y. So I will show you the direction directly the answering. So if we check and look into the F1, so we have two direction only here. See, I, J, K, only J and K consider in the some force in the force 1. So how about I is 0, so no need to write down, only J and K. And then we have I is 0, J is a negative 72, and then K in Z direction 21. And then F2 have 3 all direction. So because of should be multiplied by the angle, so the final I, J and K for the F2 should be like this. Then for resultant, we try to sum for each axis. So I from the F1 and the F2 here, and J, because I in the F1 is 0, only put the F2 here. And how about the J? J is negative 2 for F1 here, and then 41.25 for 41 for the F1, F2, sorry. And then so on until F3. So that we can calculate the resultant. Okay, like this. By the square root. To repeat this method, by calculate every angle that mentioned to every axis. So for example, cos alpha mentioned to the x, then cos beta is to y angle, and then the gamma is to refer to angle from to z axis. So this every axis angle. Now resultant already, and then angle already here. So for repeat this method, you can use this calculation method to finish all questions until to number 12. Please complete the answer and submit within 1 week to consider your attendance. I think that's all for tutorial 2 in the resultants calculation for multi-force acting in the particle. Okay, that's all.